Okay, welcome to essentially part 3 of how to make Dijkstras algorithm in Edgy. The last video in Edgy I showed you how to make this graph. The other video I showed you how to run the algorithm on this graph by hand. And now we're going to go how to build the algorithm in Edgy, and hopefully it'll all be okay. Once again, this is taken from the textbook. From page 136, something that I've showed you guys before. But I'm going to make some changes to it because I found I had to do that just to make sure, just to get it to work for me. So what we've got here now, if we have a look at, whoops, too far, 136, 136. Okay, scroll down. All right, so if we have a look at this, um, I don't like to use the when thing clicked. I just click on it. It just works for me. So I'm not going to have that part. I'm not going to have new graph or build Muddy City because I've already got that. I've already got my graph there, and I'm just doing this just so I can make it happen. From there, so we're going to say so I'm looking at this, looking at different types of variables that I'm going to need to declare. So looking at this, I'm going to need a variable called start. That's for the start node. I'm going to need a variable called end. That's for the end node. Infinity, I'm not going to create one called infinity because it's there, but if I want to, I could do that there. Then I'm going to need a node attribute of distance, and I'm going to need a variable called q, a variable called u as well. And then I think that's it. Oh, and I'll need another variable called alt, um, and then I'm going to need another variable called dist, or distance rather. So the idea is that we can have some sort of output showing exactly what the thing is. So let's go off and build this. So like I said, I need a variable. So I'm going to make some variables first, and I'm going to make a variable. I'll call it start node. Oops, don't want capital start node. I want another variable called end. Oops, end node. There's another variable called dist for distance. Let's call it distance. You know what? Let's call this final distance. Rename. Final distance. What else is there? Let's see. We're going to need one called Q. We're going to need one called U. And one called alt. Alright. Make a variable. Call it Q. Another one called U. Doesn't matter what we call these. These are just something we can store values in. And alt. Okay, so that's what we've got. Let's turn them all off. Let's not see them. Let's not mess up our beautiful graph. Okay, so looking at it, so like I said, they're the values that we've had to do. Now I'm going to make a node attribute called dist or distance. Nodes, make a node attribute, we'll call it dist. So that tells us how far it is. Okay, so then from there, now I am ready so I've made all my variables. I am ready to start building my my algorithm. So what we're going to do, we're going to take our variable and we're going to say we're going to set start node to A, and we're going to set our end node to C, because that's what we said we were doing in the videos, or in the other video. So we said we're looking for the distance between A and C. Okay, and then I'm going to, now, just as the algorithm does, I'm going to control, I'm going to make a for loop, and I'm going to say for each item of all the nodes. Now, just to show you, we can change this to say for each node of all the nodes. It doesn't matter. This is like a local variable to this subroutine, to this for loop. So we're saying for each node of all the nodes, what we're going to do. What was the first thing we did? Can anyone remember? Oh, sorry, I was expecting a response. Someone's losing the plot. We're going to set our distance for all of them to infinity. So we're going to go to set distance, or dist as we called it, for all nodes to, and we can find infinity here. going to drag that, we're going to put it in there. So now what will end up happening, if we were to run this algorithm, or even just this part of the algorithm, we should see that our distance will be there. What happens if we, okay, IDD set distance. Alright, we click on set distance. It's saying, it's throwing an error. It's saying our distance is 3 to D. I wonder why it does that. Oh, because it's still stored from before when I ran it. Anyhow, let's see what it does now. If I click that, and I say distance, set distance, still throwing an error. Infinity, see? It's like magic. Alright, so that's what we've got there. Never mind that. So let's see, we should set all of them to infinity. Yep, alright, cool. So they're all been set to infinity. I don't know why. I think it's doing that error because I haven't done the rest of the algorithm. Okay, so now, after we set that distance to infinity, what do we do to the start node? What do we set the start node distance to? That's right, we set it to 0 because we haven't gone anywhere. So we'll say, we need another set. So we'll say set distance of start node. We can drag start node in there. Start node to 0 because it's 0, 0. We know that. We know exactly what it is there. So now, if we run this, so right now, if we go there, we click on set distance, it's telling us that the distance is infinity. If I click cancel, if I run this thing and I say check the distance, and tell me the distance is, oh no, I'm hoping it's just like nothing. Set this to start node. Oh, we haven't got anything. Anyhow, that should be fine. Okay. So from there, our next step. Now we're using our other bits and pieces. So we're setting Q to all the nodes, and then we're going to set Q to sorted by ascending order. So we've got to take all the nodes and we're going to put all the nodes somewhere, and then we're going to sort them by their order. So we're going to say set Q to all the nodes, and I don't know why they do this. I just did it. I just copied it what they had there. So set that to set Q to all the nodes, and then once again we're going to set Q, duplicate, set Q to node Q. So nodes set Q to nodes. Take that out. Oops. To nodes variable Q sorted by distance ascending. I'm going to drag that away. And then from there, then we're going to set U to item 1 of Q. So we're going to set U to item 1. Whoops. Set U to item 1 of Q. Now, duplicate, put it in there. Okay. I think by default, you can have more than one thing being stored in a variable, or it'll end up putting in more than one thing, or it must set it to a list or something by default. I'm not sure. I'd love to hear what people think. If anyone has the answer, I didn't find anything. I just went and made it so I can show you guys. So that's what ended up happening there. And then what we'll do is then we'll put in this this step here, and we'll end this video. So we're going to put delete 1 of Q. So we're going to now say we're going to delete 1 of Q. We're going to delete, we're going to duplicate that, we're going to put it in there. So now what we're saying there, we're setting our start node to A, we're setting our end node to C. For each node of all the nodes, we're setting the distance to infinity, and then we're setting the distance of the start node to 0. If this throws an error, we may have to change that to A, but we'll see how it goes. Then we're taking this variable Q, which is where we're storing stuff, setting Q to all the nodes, so A to E is there, and then we're setting Q to all the nodes of Q, so the nodes of itself, sorted by the distance which is ascending. So currently they're all infinity, so we've gone A, and A will be at the bottom, A will be in 0, and that's what we've got there. Let's have a look at what Q is. Let's show Q and let's show U. And then after that, we're taking whatever is item number 1 of Q, we're putting that into variable U, and then we're deleting it. So let's see what happens. Okay, so let's see, there should not be A, and there it is. So A has been moved. So A is going to be the thing that the operations get done on first. So I'm ending the video there. The next video, we'll finish off the algorithm.